Friends, welcome to my YouTube channel. Dhanesh here. In this video, we are going to discuss about XGBoost. This is the third video on ensemble models. We will be discussing on XGBoost in detail. Let's start. I'm giving a quick introduction to ensemble models. Ensemble models combines the decisions from multiple models to improve the overall performance. This can be achieved in various ways. We will discuss. Ensemble models are meta-algorithms that combine several machine learning algorithms into one predictive model in order to decrease the variance. There we will use bagging. We will be discussing about bagging and boosting as well. Boosting is used to decrease the bias of the machine learning model, or improve predictions. We use stacking. The principle behind these ensemble models, the main principle behind the ensemble model is that a group of weak learners come together to form a strong learner, thus increasing the accuracy of the model. When we try to predict the target variable using any machine learning technique, the main causes of difference in actual and predicted values are noise, variance, and bias. Ensemble helps to reduce these factors, except noise, which is irreducible error. Types of ensemble models. Ensemble methods can be divided into two groups. One is the sequential. For sequential models, we can give example as boosting. Parallel models, the example is bagging. Sequential ensemble methods where the base learners are generated sequentially. One example is AdaBoost. The basic motivation of sequential methods is to exploit the dependence between the base learners. The overall performance can be boosted by weighing previously mislabeled examples with higher weight. Parallel. Parallel ensemble methods where the base learners are generated in parallel. Example, random forest. The basic motivation of parallel methods is to exploit independence between the base learners, since the error can be reduced dramatically by averaging. Different ensemble techniques. Sorry. There are three types of ensemble techniques we use. Stacking to increase the predictive force. For getting better prediction, we use stacking. Bagging, as discussed, to decrease the model's variance. Boosting to decrease the model's bias. Algorithms based on bagging meta-estimator, random forest. Algorithms based on boosting, AdaBoost, gradient boosting, extreme gradient boosting, light gradient boosting, cat boost, etc. Boosting. Let's discuss on boosting because we are going to discuss on extreme gradient boosting. So it's a boosting technique. Boosting is a general ensemble method that creates a strong classifier from a number of weak classifiers. Boosting is often considered as homogeneous weak learners. When we consider stacking, it's heterogeneous weak learners. Here it is boosting. It's often considered as homogeneous weak learners, learns them sequentially in very adaptive way. A base model depends on the previous ones and combines them following a deterministic strategy. This is done by building a model from the training data, then creating a second model that attempts to correct the errors from the first model. Models are added until the training set is predicted perfectly or a maximum number of models are added. AdaBoost was the first really successful boosting algorithm developed for binary classification. It is the best starting point for understanding boosting. Boosting is a sequential process where each subsequent model attempts to correct the errors of the previous model. The succeeding models are dependent on the previous model. As discussed, unlike bagging, that mainly aims at reducing variance, boosting is used to reduce the model's bias. Boosting, like bagging, can be used for regression as well as for classification problems. Two important boosting algorithms are AdaBoost and gradient boosting. Boosting is used to create a collection of predictors. In this technique, learners are learned sequentially, with early learners fitting simple model to the data and then analyzing data for errors. Consecutive trees, random sample, are fit and vary at and at every step the goal is to improve the accuracy from the prior tree. When an input is misclassified by a hypothesis, its weight is increased so that next hypothesis is more likely to classify it correctly. This process converts weak learners into better performing model. Algorithms based on boosting are AdaBoost, GBM, gradient boosting, XGM, extreme gradient boosting, light GBM, CatBoost. All these are all algorithms based on boosting techniques. So today we are going to discuss one of the most important boosting algorithms, that is XGBoost or extreme gradient boosting. XGBoost is one of the most popular machine learning algorithms regardless of the type of predictions task at hand, regression or classification. It's best. XGBoost is well known to provide better solutions than other machine learning algorithms. In fact, since its inception, it has become the state of the art machine learning algorithm to deal with structured data. When you deal with unstructured data, deep learning or neural networks are best suited. Here, structured data, we will go with XGBoost is the best one. XGBoost is a decision tree based ensemble machine learning algorithm that uses a gradient boosting framework. You are familiar with, you can watch the gradient boosting framework video to understand it much better. XGBoost algorithms was developed as a research project at the University of Washington. What are all the advantages of XGBoost? Speed and performance. Originally written in C++, it is comparatively faster than other ensemble classifiers. Core algorithm is parallelizable. Because of the core XGBoost algorithm is parallelizable, it can harness the power of multi-core computers. It's also parallelizable onto GPUs and across networks of computers, making it feasible to train on very large data sets as well. Consistently outperforms other algorithm methods. It has better performance on a variety of machine learning benchmark data sets. Wide variety of turning parameters. XGBoost internally has parameters for cross-validation, regularization, user-defined objective functions, missing values, tree parameters, scikit-learn compatible API, etc. XGBoost continuing. XGBoost extreme gradient boosting belongs to a family of boosting algorithms and uses a gradient boosting framework at its core. XGBoost is a software library that you can download and install on your machine, then access from a variety of interfaces. It can also be loaded and used in various languages and interfaces such as Python, C++, R, Julia, Scala, and Java. XGBoost differentiating factors. A wide range of applications can be used to solve regression, classification, ranking, and user-defined prediction problems. Probability runs smoothly on Windows. Portability runs smoothly on Windows, Linux, and all types of operating systems. Languages it support all major programming languages including C++, Python, R, Java, Scala, and Julia. Cloud integration supports AWS, Azure, and Yarn clusters and works well with Flink, Spark, and other ecosystems. XGBoost system optimization, parallelization. XGBoost approaches the process of sequential tree building using parallelized implementations. We already discussed tree pruning. XGBoost uses max underscore depth parameter as specified instead of criterion first and starts pruning trees backward. The depth first approach improves computational performance significantly. Hardware optimization. This algorithm has been designed to make efficient use of hardware resources. This is accomplished by cache awareness by allocating internal buffers in each thread to store gradient statistics. Distributed computing for training very large models using a cluster of machines. Out of core computing for very large data sets that don't fit into memory. Cache optimization of data structures and algorithms to make best use of hardware. Algorithmic enhancements, regularization. It penalizes more complex models through both lasso, L1, and bridge L2 regularization to prevent overfitting. Sparsity awareness. XGBoost naturally admits sparse features for inputs by automatically learning best missing values depending on training loads and handles different types of sparsity patterns in the data more efficiently. Weighted quintile sketch. XGBoost employs the distributed weighted quintile sketch algorithm to effectively find the optimal split points among weighted data sets. Cross validation. The algorithm comes with built-in cross validation method at each iteration, taking away the need to explicitly program this search and to specify the exact number of boosting iterations required in a single run. Block structure to support the parallelization of tree construction. Continue training so that you can further boost an already fitted model on new data. XGBoost model features. The implementation of the model supports the features of the scikit-learn and R implementations with new additions like regularization. Three main forms of gradient boosting are supported. Gradient boosting algorithm is also called gradient boosting machine learning, including the learning rate. Stochastic gradient boosting with sampling at the row, column, and column per split levels. Regularized gradient boosting, both L1 and L2 regularization. There are alternatives for XGBoost. Machine learning is a very active research area, and already there are several alternatives to XGBoost. Microsoft Research recently released Light GBM framework for gradient boosting that shows great potential. Cat Boost, developed by Andex Technology, has been delivering impressive benchmarking results. That's all about XGBoost. Thanks for watching. Please like, share, and subscribe. Thanks a lot.